Now let's understand what are IRQ numbers in this lecture. This is the generic concept applicable to any microcontroller. So let's take an example of this simplified picture of button interrupting the processor. Here you can see button is connected to PA0, that is port A's 0th pin, which actually issues the interrupt to the processor over EXTI 0 line in STM32F4XX based microcontroller. This we just saw in our previous video. So the IRQ number for this line is decided by to which line of the NVIC or the interrupt controller it is connected, and this is decided by the MCU vendors. The NVIC of ARM Cortex-M4 processor has totally 240 lines for the external interrupts. To find out the IRQ numbers, you have to refer to the vector table given by your MCU vendor. For 407XX microcontroller, this is the table you have to refer. This table has different columns here. Let's explore one by one. The first column is the position, which is also called IRQ number, which means position on NVIC where an external interrupt is connected. Here you can see that EXTI line 0 is connected to the NVIC at position 6. In other words, we can say that IRQ number of the EXTI line 0 is 6. Similarly, EXTI 1 is connected to NVIC line number or position 7. So its IRQ number is 7. EXTI 2 is connected to the NVIC line number or position number 8. So its IRQ number is 8, and so on. All these GPIO pins which are going to interrupt the processor over EXTI 0 will have the IRQ number 6. Now let's open up the MCU Specific Header file which we explored in the beginning of the course to see whether this matches with the IRQ definition defined in the header file. Here I am in the MCU Specific Header file, and here is an interrupt definition. Yes, you can see here header file declares EXTI IRQ number as 6. EXTI 1 IRQ number as 7, and so on. Great. With this lecture, hope you learnt about how to find out the IRQ number of different peripherals which issues interrupts to the processor. Remember that every MCU data sheet or reference manual will have the table similar to this. From there, you can find out IRQ number details. The second column in this table is priority of the interrupts, and the third column tells you whether priority is configurable or not. In our case, all these interrupt priorities are configurable. And the fourth column just tells us which interrupt it is. And finally, the fifth column, which lists out all the vector addresses for different interrupts. For example, when the interrupt occurs on the IRQ number 6, processor expects the address of the IRQ handler to be present in this address, so it can jump to your IRQ handler. So who will initialize these addresses with the valid IRQ handle addresses? The answer is this is usually done by the vector table of the system startup code, which is our next topic of discussion.